So I'm going to create this short video just kind of explaining the answers just in case you guys have any questions, because I know a lot of these are confusing and I really want to make sure we're the best prepared that we can be for the exam. So this first one was just chain rule. And so we just take that outside 2 term and it's kind of like having, y equals box squared. So the derivative would be 2 times the box to the first power times, and then we chain it, the derivative of the box. So we got 2 times x cubed plus 1 to the first power, and times the derivative of the inside was 3x squared. You always want to multiply kind of like your outside terms. So we get 6x squared times x cubed plus 1, which was e. Next one was quotient rule. We just really need to remember low, d high, minus high, d low, all over low squared. And then from there, we're just kind of foiling it out. And we will get our final answer. The 6x's cancel out. And so we get negative 5 over 3x squared plus 2 squared. After that, we have a chain rule. And this actually has kind of a double chain, I guess. And so the reason it has a double chain is it's the ln of something. But then within that, we have e to the something. So when we do the first chain, the very outside term is the ln. So we're going to cross out the ln and do 1 over x plus 4 plus e to the negative 3x. Then times, then the derivative of the inside, the derivative of x is 1. Plus the 4 goes to 0. Plus e to the negative 3x's derivative will be e to the negative 3x times negative 3. Then we can take this entire term and move it to the top. And we get 1. Now I just moved the negative 3 in front. So 1 minus 3 e to the negative 3x. Then we wanted to find f prime of 0. Don't worry about simplifying, just immediately plug in. Once you take the derivative, immediately plug in. It's always easier. So 1 minus 3 e to the 0 over 0 plus 4 plus e to the 0. Remember that anything to the 0th term is just 1. So this is 1 minus 3 is negative 2. And 4 plus 1 is 5. Okay, next we have a product rule, another product rule with a chain inside, right? Because sine of 2x will have a chain. So the derivative of the first is 2x, leave sine of 2x alone, plus x squared we leave alone. The derivative of sine of 2x will be cosine of 2x, and then times 2 for the chain part. This becomes 2x sine of 2x plus, we're going to multiply the outside terms, so 2x squared cosine of 2x. Then we can factor out a 2x from each term. So we get 2x times sine of 2x plus x cosine of 2x. Next, we have another one of these inverse equations. And so I always start off with, if I'm asked for g prime of 2, I always start off with g of 2 in this bottom left table. So g of 2 is 1, f of 1 is 2. We just flip them. Now this one did have an equation, right? So this is one of those ones that I was talking about with an equation. So if we have an equation, our top right box, we put in the equation. The equation is 3x squared plus 1. And then in the bottom right box, now we plug in 1 into our equation. So 3 times 1 squared is 3. 3 plus 1 is 4. And then to get g prime of 2, we flip that 1 over 4. Next one was a calculator question. Should be very easy. Just take a look at how I typed in my calculator and make sure that you did the same. Same thing, this guy's another calculator question, but actually I ended up doing this one without a calculator. So for g of x, we had it was x times f of x. So for g of 2, x is going to be 2, and then f of 2 is going to be 3. 2 times 3 is 6. Then for g prime of x, we do product rule. The derivative of the first is x. So the derivative of x is, 1, and then we leave f of x alone. Then plus, we leave the first term alone, x, and then times f prime of x. So f of 2 is 3. Then plus 2 times f prime of 2 is negative 5. So we get negative 7. Y minus 6 equals negative 7 times x minus 2. Next, we have a chain rule question. This is like kind of a table question. So we have h of x equals f of g of x. This is very common. So h prime of x will be f prime of x. The outside, we'll cross that out, of g of x, and then times the derivative of g of x will be g prime of x. Then we just plug in 1. G of 1 is 2, so this will be f prime of 2 times, and then g prime of 1 is negative 3. Then f prime of 2 is negative 4, so negative 4 times negative 3 is 12. Next, we have another inverse equation. And so we're going to start off g prime of negative 2. We're going to start off in the bottom left with g of negative 2, which is 5. Then we flip them. So f of 5 is negative 2. Then we're going to cross out this because we don't have an equation. And then we put f prime of 5, and they gave us was negative 1/2. We flip that, we get negative 2. All right, next up we have another chain. This is a double chain, right? Because it's sine of something and then e to the something. So outside is the sine. We take the derivative of sine, we get cosine. We leave e to the negative x alone. Then times, for the derivative of e to the negative x will be e to the negative x times the derivative of the negative x is negative 1. So we're going to move that negative 1 all the way to the front and the e to the negative x to the front. So we get negative e to the negative x times cosine of negative e to the x. That's how the answer looked. But just be aware, hypothetically, anything with a negative exponent could have moved down to a denominator. So watch out for this answer as well. Next, what is our instantaneous rate of change? In other words, f prime at x equals 2, so f prime of 2. So this was quotient rule. Low d high minus high d low all over low squared. Now you can distribute and simplify, but I find it much easier to immediately plug in if that's what we're doing. So I'm just going to plug in. 2 minus 1 is 1. 2 times 2 is 4. Minus 2 squared is 4 minus 2 is 2 times 1 over 2 minus 1 is 1 squared. We get 4 minus 2 over 1 is 2. Next, we have a chain rule, right? Tangent of something other than x. So the derivative of tangent is secant squared of 2x, and times the derivative of 2x is 2. Right, so bring the 2 to the front, 2 secant squared of 2x. So when we plug in pi over 6, 2 secant squared of pi over 3, right? 2 pi over 6 is pi over 3. And for secant squared, we know that's basically cosine on the bottom, like it's 1 over cosine. So you can write this as 2 over cosine of pi over 3 squared. That's 2 over 1/2 squared, 2 over 1/4. Multiply the top and the bottom by 4 to get rid of the fraction, and we get 8. Next, this one can be a little bit tricky, and that's because of the part 3. So question 1 asks about the limit as x approaches 2 on the left and the right. We're going to plug those into the original. So you can do how I wrote it, or what I would have done on a test is literally just plug those into the original. So ln of 1, that's 0. Then 4 times 2 is 8. 8 minus 7 is 1. 0 and 1 are not equal to, so a is not true. Then for number 2, I would have just plugged them into the derivatives. So let me use another color. So here's our derivative. I took the derivative, right? The derivative here is chain rule. 1 over 4x minus 7 times 4. And then derivative 4x minus 7 is just 4. So again, I'm going to plug in 2. So this is basically going to be 4 over 8 minus 7 is 1. Or 1 over, 1 times 4 is 4. So we get 4. And then if I plug in 2 here, I get 4. These are equal, right? Those are equal. So that means that my limit as x approaches 2 on the left of the derivative is the same. Now, normally when this is true, you'd think, oh, that means yes, it's differentiable. But remember, if it was differentiable, it had to have been continuous. So as soon as rule 1 fails, immediately rule 3 fails. So that's why this one is only choice 2. All right, next we have, we already did that one. We have this guy. So what are all of our values for a and b, where f will be differentiable at x equals 2? So first we take our originals. 2 plus 2b equals a times 2 squared. So it gives us 2 plus 2b equals 4a. So I did that. Then I took the derivative side, and we had 1 for the derivative of the top, and then 2ax for the derivative of the bottom. And so we set those equal to each other. We get 1 equals 4a because we plug in x for 2. So we get a equals 1/4. We plug in the 1/4. 2 plus 2b equals 4 times 1/4. Solve for that. You should get negative half. All right, these two are calculator questions. Super easy. Just type them into your calculator. Pause the video if you need to here, but I'm not going to spend much time on it. The only thing I do want to point out, I kept getting 0 for number 5, and I got 0, and I got 0, and I got 0. And the reason I kept getting 0, I couldn't figure it out at first, and then I realized is I had used t's, but I had accidentally used x here. So if this is x, or if like your variables don't all match up, then you'll end up getting a wrong answer. So just be extra careful If you use t's, everything's a t. If you use x's, everything's an x. Okay, our next question is down here. And so when you see this dx, that's just another way of saying the derivative of, right? So this is that chain rule. So the outside is f, so f prime of g of x times g prime of x. Then we plug in 3. So g of 3 is 1. And so we get f prime of 1 times g prime of 3 was negative 5. And f prime of 1 is 3. So 3 times negative 5 is negative 15. Okay. And then this one says calculator. You could have used your calculator to solve it. I did it by hand. But if you needed to type ln of 1 into your calculator, I suppose you could have, and you would have gotten 0. So we just basically plug in 1, and we set them equal to each other. So cube root of 1 is 1 plus k equals ln of 1 is 0. K equals negative 1. Again, you could have used your calculator. I did it by hand. All right, next up, we have, this one's a little bit tricky for the explanation, right? Because g of t is already the rate. So whenever you already have the rate, and then you want to take the derivative, that becomes the rate of the rate. So we just need to be careful. The derivative part should be easy. For the units, we had tons per hour. If you take an integral, you chop off the per hour. If we take a derivative, we add on a per hour. So we put tons per hour squared. So this is the rate of the rate, right? The rate of the rate, because we're taking the derivative of the rate. And then just, everything else is just kind of from your sentence starters. So the rate of unprocessed gravel in tons per hour squared is negative 24.5875 at time 5 hours. Okay, next, this one says for x is not equal to 0, express f prime of x as a piecewise function, and then find the value of x for which f prime of x equals negative 3. The first part is pretty easy. So we just take the derivative at the top, which derivative of negative 2 sine of x is negative 2 cosine of x. The e to the negative 4x will be e to the negative 4x times negative 4. So I just brought the negative 4 in front. So this is easy. That was a point or 2. The second part's a little bit tougher because it's saying, when is f prime of x equal to negative 3? So this is kind of working backwards. It's not saying plug in negative 3. It's saying set both equal to negative 3. So we're going to set the top equal to negative 3 and the bottom equal to negative 3. On the top, this was a non-calculator question, which also made it kind of tricky. When we divide by negative 2, we get cosine of x equals 3/2. This is like saying, where does cosine give us the answer of 3/2? Well, on your chart, there's nowhere. And if you kind of think of your unit circle or even the graph, you need to remember that the minimum cosine can ever be is negative 1, and the maximum it can ever be is positive 1. So it can never actually reach 1.5. So this is no solution. On the right side, we divide by negative 4. We get e to the negative 4x equals 3/4. Then I change this to 1 over e to the 4x equals 3/4. I can flip both of them. So that gave me e to the 4x equals 4/3. I took the ln of both sides, right? E and ln cancel, so we get 4x equals ln of 4/3. Divide by 4, 1/4 ln of 4/3. You can also write in like ln of 4/3 all over 4. Okay, next one, we've done this a few times, is the h prime of x. So the outside is f prime of g of x times g prime. This really almost needs to be memorized. It's so common. Right, so we get h prime of 3 equals f prime of g of 3 times g prime of 3. We've done this a bunch of times. You get 6. If g is the inverse, then write an equation for the tangent line. So be careful that we're doing the full tangent line. So I'm going to do x1 is 2 because they gave me x equals 2. Then for the rest of it, I kind of did the table. So in the bottom left, I do g negative 1 of 2 equals 1. Right, and the reason I got that is that for my inverse, it's kind of like what y value for g. So like what y value gave g of x equal to 2. Well, where was g of x equal to 2? It was at 1. So that's why g of 2 is equal to 1. Right, it's working backwards with inverses. Then up here I flip it, g of 1 equals 2. And then in the bottom right I say g prime of 1 equals 5. So, the derivative of g of x, at x equals 2 would be 1/5. So that's where the m comes in, right? We flip that guy. And for the y, it's just that first guy. So we get y minus 1 equals 1/5 times x minus 2. That should have a closed parenthesis. Then here, let f be the function f of x equals k squared root of x minus ln of x. Find f prime of x, find f double prime of x. This is just a good question for practice, right? Remember, the k is a constant, so I'm going to leave it in front. And we have that rule we memorized, 1 over 2 squared of x, and then ln of x, we also should have it memorized, minus 1 over x. That should be easy. Most of you guys should have gotten that right. Second one's a little bit trickier. So what I did to help myself out is I rewrote the derivative. So I said that this is x to the negative half power. So I said it's k over 2 times x to the negative half power. I brought this up and changed it to my exponent form. So for this, the k over 2 is going to hang out, right? Negative 1/2 I bring to the front, so negative half times k over 2 times subtract 1, x to the negative 3f's, and then reverse power rule plus 1 over x squared. On free response, just leave that as your answer. Don't even worry about simplifying it. Technically, if we simplified it, we would have gotten something like negative k over 4, x to the 3/2, so you could even have square root of x cubed, plus 1 over x squared. But honestly, I wouldn't even worry about it. It's just a chance for you to mess up, so don't do it. Okay, next one is f differentiable, and use the definition of the derivatives. So basically what they're just asking is, find the derivative on the left, which is up 2 over 3, right? Up 2 over 3. And then find the derivative on the right, which we don't know, but we know that the derivative is negative, right? If this is a curve, it's negative. It kind of looks like it's almost negative 1 right there, but we just know it's a negative value. So now, writing it out formally, because it's a free response and they asked us to use that definition of the derivative, would be the limit as x approaches 0 on the left of f of x minus f of 0 over x minus 0 is 2/3. That's the slope on the left side. The limit as x approaches 0 on the right side, we don't know what it is, but it's less than 0. If you had put negative 1, you probably would have been fine, honestly. So those are not equal to each other, so f is not differentiable. Okay, B was tricky. If you missed this question, by the way, this question honestly was like super, super tricky. This is way trickier than anything that's going to be on your final. And most likely it's going to be trickier than anything on your AP exam. But there are always certain questions that are tricky and then other questions that are more straightforward. So this is one of those tricky ones. So it says, for how many values would the average rate of change of f on the interval from a to 6 be 0? So if you really break this down, what was our formula for average rate of change? Well, f of b, which is 6, minus f of a over b minus a. So if we do that, we get f of 6 minus f of a over 6 minus a equals 0. Now, to set that equal to 0, really you just need to worry about the top being equal to 0. So f of 6 minus f of a equals 0. That means when does f of 6 equal f of a? Well, f of 6 was 1. So you could have even written like, when does 1 equal to f of a? And then if you look, we have 2 points, right? 1, 2 points where the graph crossed 1. So, all right, this next one I left blank, and I left it blank because honestly it is really tricky. And the first time I did it, I got it completely wrong. I totally misread it. So if you got this one wrong or you were really confused about it, don't worry about it too much. It's a really, really tough question. So make sure that everything we look at, we're talking about G. They gave us a graph of f prime, but we have this formula here. So again, this was just a weird question. But so for A, right, x1 is going to be 1. That's kind of obvious. For y1, we need to do g of 1. So g of 1 is e to the f of 1. Well, f of 1 is not in our graph. Our graph is for f prime. But up here they gave us f of 1 was 2. So this is e to the second power. We're just going to leave that e to the 2. Then for m, we need to first do g prime of x. So g prime of x, this is going to be chain rule. So that's going to be e to the f of x times the derivative of the box, f prime of x. So that means m is going to be e to the f of 1 times f prime of 1. Now, e to the f of 1, we just said f of 1 was 2, so that's e squared. Times, now f prime of 1 is negative 4. So it's going to be negative 4 e squared. So we're going to write this as y minus e squared equals negative 4 e squared times x minus 1. And that's our answer. It's a weird looking answer, but that's correct. Okay, B asks about a local maximum. And it's tough because it's for G, not for F prime, but actually it's not too different. Okay, and we're going to see that because we always are going to take G prime of X and set that equal to 0. Well, G prime of X, we already found that up here, was e to the F of X times F prime of X. We're going to set that to be 0. Now, you want to kind of set both sides to 0. So e to the F of X could be 0, or F prime of X could be 0. Now for the e to the f of x, that's going to give us no solution. If you want to see it, take the ln of both sides. ln of 0 is dne, so this is no solution. Right? You kind of want to memorize that e to the x is always going to give a positive answer. So e to the x or e to the f of x or e to the anything always gives a positive answer. It cannot equal to 0 or a negative. For f prime of x, we're going to just look on the graph. Where does this graph hit 0? At -1 and at 3. So x equals -1 and 3. So we're going to do our number line. I'm going to cap it at 3.2 and 1.2, -1.2. We're going to label it G prime. And we have critical points at -1 and 3. So I'm going to plug in something like -1.1, something over here. We get positive. And then we need to also plug into e to the f of x. But e to the f of x, we just looked at the graph. We said this part's always going to give a positive. So positive times positive is positive. Then in between -1 and 3, we're negative. Positive times a negative gives negative. And after 3, we're positive. Positive times positive gives positive. So we're going to say that, increasing, decreasing, increasing. So g of x has a local max at x equals -1 because g prime of x changes from positive to negative at that point. All right, C is definitely weird as well. This whole question, like I said, is a little bit tricky. So g double prime of x equals e to the f of x times f prime of x squared plus f double prime of x. And they want to know, is our graph concave up or concave down at that point, essentially? Is g double prime positive or negative or 0? So we want to kind of look at g double prime and just kind of think about, do we know those values or -1, right? Yeah, g double prime -1. So e to the f of -1 then times f prime of -1 squared and plus f double prime of -1. So for e to the f of -1, this is a little bit tricky because it is at -1. But we do know that it has to be positive, even though we don't know the value, right? Like here we knew f of 1 was 2, so we don't know it's like 2. But what we know is that e to anything, this e to anything, that whole thing is going to be a positive number. Then times, now for f prime of -1, we do know f prime of -1. F prime of -1 is this point here, which is 0. So 0 squared is still 0. And plus f double prime of -1, well, this is actually really tricky, okay? A lot of students said it was positive because it looks concave up here. But remember, this is the graph of f prime, not the graph of f. So how do we go from the graph of f prime to f double prime? We take a derivative. So it's the slope. So the slope of this graph here is negative. I don't know what it is. It looks like it's around -1, but it's negative. So, plus a negative. So really what we're getting at here is that this is a positive times a negative. And so that's going to be a negative. So this is really tough, but we can basically say that g double prime of x is less than 0, is negative, because e to the f of -1 will be positive, right? F prime of -1 will be 0, and f double prime of -1 is less than 0. This is probably the only one I need to explain. right? Because the graph is decreasing. The graph, I'm going to say of f because we have two terms, is decreasing at x equals -1. Therefore, g double prime of -1 is less than 0. So kind of showing our work on the left and explaining, the values on the right will work. Okay, and then D, I don't have a whole lot of room. I'm just going to do that. So for D, this one's a little bit tricky, but basically what we want to look at is, and the reason it's tricky is when we see average value, or sorry, average rate of change, we know like FB minus FA over B minus A, we want to just make sure we're doing it for G prime, right? So there's our interval. So this is not G of 3, but because we're doing it for G prime, it's G prime of 3 minus G prime of 1 over 3 minus 1. Now as a reminder, right, G prime of x was this e to the f of x times f prime of x. So we're going to get this being e to the f of 3 times f prime of 3 minus e to the f of 1 times f prime of 1 all over 3 minus 1 is 2. Now, we don't know what f of 3 is. Anytime that happens, a lot of times what will end up being the case is we're multiplying by 0. And that's the case here because f prime of 3 is 0. So anything times 0, this whole thing goes to 0. So we get 0 minus, so we get negative. E to the now f of 1 we do know about. They gave us that in the stem was 2. So this is e squared times, and then f prime of 1 we know on the graph. If you look at the graph, they give us -4. All over 2. That's going to give, the negatives cancel, so that's going to give us 2e squared. Okay, again, very tricky question. Doable, but tricky. You'd probably pick up some points. But this is one of those questions that on an AP exam, this is probably the hardest question on the whole exam. So this is something where it's like, hey, can I just figure out how I get a couple points somewhere? All right, so anyways, we'll move on. This question is a calculator question. Should be very, very easy. You could have graphed it. I used the solve button, but if you wanted to graph it, you could also graph it and then do the zeros. If you graph it, just set like your window settings so you get that 0.12 and x for your x minimum and your x maximum. Okay, next up we have, this question is a cubic polynomial function. And so they want to know the values of a and b if we have a local minimum at -1 and a point of inflection at -2. So for the minimum, we're going to take the derivative, plug in -1 to x and set it equal to 0. And we get, basically, if we simplify this, we get 12 minus 2a plus b equals to 0. Then for the point of inflection, we're going to take the second derivative, so take the derivative of that, and then plug in -2, set that equal to 0. We get -48 plus 2a equals 0. We can solve here. We get a equals 24. Take the 24, plug it in, and we'll get b equal to 36. Okay, and then this next one is kind of a longer one. And this one's, honestly, this one's really important to understand the distinction between like a horizontal tangent versus just a other critical point. And so they ask us to find the x values where we have horizontal tangents and then determine if x is a local maximum, minimum, or neither. Now, be careful because when you take the derivative here, it's already given. We need to make sure we set it to 0 and d and e. Now, the issue is that the 0 case, those are the only two that are horizontal tangents, right? The 0 case is when we have horizontal tangents. The d and e case, the bottom, when we set the bottom equal to 0, those are not horizontal tangents. That's when the graph literally has a vertical asymptote, like it doesn't exist or it might have a hole, right? So those points are not horizontal tangents, but they still are critical points. So we still include them on our number line. Now they can't be maxes or minimums because they're like a hole or a vertical asymptote where we just don't have an answer. I think I said tangent earlier, I meant asymptote. So anyways, the top, set it equal to 0, we get plus or minus square root of 2. The bottom, we get 0. We make our number line. We plug in. I plugged in like -10 squared was 100. Minus 2 is 98 over -10. I got negative. Then I plugged in like -0.1. -0.1 squared is 0.8. 0, 1. Minus 2 is a negative over negative 0.1 is positive, negative over negative over negative. Then like 0.1 squared, the top is going to be negative, the bottom is going to be positive. We get negative. Then say like 10 squared, we get positive over positive. So the horizontal tangents are plus or minus square root of 2 because h prime of x was 0. And then both of these points are both local minimums because the graph changes from negative to positive. Now, 0 is kind of weird. 0 is not a maximum. Even though it looks like 0 is a maximum, we need to be really careful. See how it says like for all x is not 0? And if we think about the graph, right, that's going to be a vertical asymptote. So x is a vertical asymptote. It's not a maximum. So just be careful about that. Okay, next they asked about concavity. So for concavity, we have to do the second derivative. So low d high minus high d low over low squared. Again, we're going to set the top and the bottom to 0 to give us the 0 in the d and e cases. So the top to 0 is no solution because when we try to take the square root of a negative, we can't. The bottom to 0 gives us 0. So we plug in and we get positive and positive. So h is concave up for negative infinity to 0, union 0 to infinity. You also could have said for like, all x where x is not 0, that could have worked as well. Right, because h double prime is positive, make sure you mention that. Then the last one was our tangent line. x1 was 4. For y1, we were given that h of 4 was negative 3. And then for m, we're going to plug it into x squared. So 4 squared is 16, minus 2 is 14 over 4. 14 over 4 gives us 7 halves. So y plus 3 equals 7 halves x minus 4. Then they asked us, would the graph lie above or below the tangent line? And so because the graph is concave up, right, you can even graph it if you need to, concave up, we're going to be below the tangent line. So you say the tangent line is below the graph because h prime of 4 is greater than 0, so h is concave up. All right, next one was honestly not too bad. I think this is a good question to study. So is f continuous? We do our 3 rules. Make sure you do all 3 rules. You can read through those on your own. I don't think this is too bad. We've gone over it a lot. And the next one is asking if g is differentiable, what are the values of k and m? We've done this one a couple times. So we set them equal to each other. And we get 2k equals 3m plus 2. Then we take the derivative. Now the derivative of this guy, right, the k is going to stay in front. So it's k times 1 over 2 squared root of x plus 1. Technically chain rule times 1. And the bottom is m. So we're going to set these two guys equal to each other and plug in 3. K times 1 over 2 squared root of 3 plus 1 is k times 1/4. I move the 1/4 to the front. And so that's my second equation. Both of them have a k, both of them have an m. So we need to isolate for m or k, we already have, and then plug that in. And then you can go ahead and solve. You should get k equals 8/5. You take the 8/5, plug it back in, and you get m equals 2/5. This is a really good question. Okay, I really want you to study this for the final. Right, and then lastly, this one, I gave you the answer already. Just kind of take a peek at it, see if it makes sense. It was kind of weird, so I gave the answer. I probably should have done that for that other really complicated one. But anyways, this one says the twice differentiable function is defined for all real numbers. And we're given f of 0 equals 2, f prime of 0 equals negative 4, and f double prime of 0 is 3. So they give us the function g of x equals e to the ax plus f of x. They want us to find g prime of 0 and g double prime of 0 in terms of a. So this is chain rule right here, e to the ax times a, they move the a to the front, plus f prime of x. When we plug in 0, right, anything e to the 0 is always 1. So when we plug in 0, we get a times 1 minus 4, we get a minus 4. Then we do the derivative of this guy. The a is a constant, it stays there. So e to the ax times a, and then there was another a, so it becomes a squared. Then plus f double prime of x. Again, we plug in e to the 0 is 1, and they gave us f double prime of 0 was 3, so we get a squared plus 3. So that actually wasn't too bad. And in the bottom, the function h is given by h of x equals cosine of kx times f of x. For all real numbers, where k is a constant, find h prime of x, and write an equation to the tangent line. So basically we do the x1 is 0, y1, we're going to plug in 0 into this. So cosine of 0 is 1, and f of 0 was 2. 1 times 2 is 2. Then for m, we're going to take the derivative. We're going to have to do a product rule. So we're going to take the derivative first. They did this backwards when they showed that. That's okay. So the derivative first would be negative sine of x, kx times k, and then the original first, and then plus, then leave the first alone, times f prime of x. So again, if you do it backwards, not a big deal. You plug everything in, and you should end up with h prime is negative 4. So we get y minus 2 equals negative 4 times x minus 0. All right, so there's that. Email me if you have any questions. I hope this helped, and good luck and keep studying.